What's up guys, welcome back to the channel. Today in this video we'll be doing this question paper that you see here. So this is a national certificate mathematics N4 and this paper was written on the 29th July 2014 and it took about 3 hours. So it was written exactly at 9 o'clock till 12 o'clock. So on this video though, we're gonna focus only on question 5 because we have already made videos on question 1, 2, 3 and 4. If you want to watch those videos, you can go to the description. There's a link that will lead you to those videos, and also that icon on the top right will pop up with the link. So I'm gonna leave the timestamps of this video when it comes to questions so that you can able to watch the question that you are interested in, or you can watch the whole question. Alright guys, so let's go to question 5 and let's solve it. So here is our question 5 guys. As you can see, it consists of 4 questions, 5.1, 5.2, 5.3, 5.4, which has 2 questions within it. So we're going to start with 5.1 and solve it. So I'm going to copy this question and paste it where there is space and solve the question. Guys, here's 5.1. They want us to simplify here. So as you can see, there is a sigma here and dx. Basically, this means that we must integrate the expression that you see here. So before you integrate, you need to simplify this expression here. From the word go, I can see it's actually a double angle identity. So I've already made videos on double angle identities. You can go to the description and click on that link, and also there is an icon that will pop up on the top right of this video. Go and watch it, because this here is actually the double angle identity. So when you simplify, you leave the sigma and then you simplify there. So this one we know that is cos 2x. So the expression that we see here inside the bracket is actually that one. So it's a double angle identity. So don't forget to write your sigma and your dx. So from here now you can start integrating. So when you integrate this one guys, it's gonna be y is equal to sine 2x, and then we divide by the coefficient of x here, which is gonna be 2 plus c. So basically this question here was not difficult guys, it was straightforward. You just need to know your integrals and know how to integrate the trigonometric functions. Alright guys, so if it so happened that you were lost or you didn't understand this question, you can go back to the point where you got lost, or you can ask a question on the comment section. And if this video helped you to understand how to integrate this question here, don't forget to like and also share the video. If you haven't subscribed to the channel, subscribe to the channel. And guys, we are done with 5.1. Let's go and do 5.2. So let's look at question 5.2. Now question 5.2, they want us to integrate the following expression here. So I'm going to copy that question, paste it where there is a space, and we solve it. So let's look at 5.2. As you can see, they want us to integrate the following here. Now we have different types of integrals here, but I've noticed that when I look at this, we have the exponential here, and this one also is exponential, and that one is exponential. And this one here, it's the standard, and that one is also the power rule. But then before we integrate, we need to check which term that needs to be simplified. When I look at this question here, this term here needs to be simplified. So you cannot integrate with the root and also with an x on the denominator. So we need to simplify this term here. So let's simplify it. So remember, when we are simplifying, the sigma and the dx, they always remain there. So let's start. The first term, which is e to the power of 5x, is already simplified. The second term, which is 3 pi to the power of 3x, it's already simplified. Minus 10 to the power of 2x, it's also simplified. Now, let's look at the fourth term. Now, let's first change this root into exponent. We know that the square root is actually the exponent of half. So we write half there, plus p. Also, this one is simplified. So we're going to continue simplify it further. So let's continue. Remember, the sigma and the dx, they remain. Right, so let's start with the first term, the second term, we're just gonna rewrite it as it is. This is not necessary, guys. I'm just doing it for you to understand it way much better. Now let's go to this term here, the second last term. Now look, we are integrating with respect to x. So the thing that we need to do here is to take this x from the denominator to the numerator. So when we do that, the exponent of this x here, which is the power of half, is going to be negative half. And then we're going to leave that 2 as a coefficient underneath them, plus p. So when it's like this, guys, it is ready. Don't forget, guys, you equate to 1. Now, remember I said earlier on this question that the first 3 terms are exponential integrals. Remember, guys, the formula for exponential integral, it goes like this: when a given k, which is the coefficient of a to the power of nx, when you integrate this one here, is going to be k a to the power of nx divided by n natural log then a plus c. Let us not forget this c means that is the indefinite integral. Just in case you don't know this formula, I already made videos on this type of integral. I will leave the link on the description, and also the video will pop up on the top right of this video. Go and watch for you to understand better. So let's do the first term here. So as you can see, e is actually our a in this case, and then n is 5x. All right, then we divide by, now remember we must multiply by n in this case, which is 5, natural log then e. Right, all we do is just substitute these values on our formula there on our top right. Let's go to the second term, which is also the exponential. So we're gonna write this as it is. Right, then we divide. As we divide here, now this time around we have n as 3, and then we have natural log, and then we have this as our pi. Right, and then we continue here. So we have 10 to the power of 2x divided by our n here is going to be 2, natural log, which is going to be 10. Right, so we are done with the first 3 terms which needed us to use this exponential derivatives. Now the second 2 that are following is the power rule. We're going to use a different formula for them. So this one is basically very, very simple. It goes like this: when you are given k multiplied by x to the power of n, and then when you find the integral of this, is going to be k, and then we have x to the power of n plus 1 divided by n plus 1. Basically, this is how you do the power rule. Just in case you don't know about this formula, you can go to the description. I've left the link where I explain this formula further, and also you can go to this icon that will pop up on the top right of this video. Go and click on those to watch this one further. Right, so let's continue. So we say plus. Now we know that we have x to the power of negative half plus 1. But let us not forget this is divided by 2. And also we need to divide by the following: negative half plus 1. There we go. Plus. So let's look at the last term here, which is p. Since p doesn't have x, I did mention this also when I introduced the power rule. You just multiply by the variable that we are integrating with respect to. You're just going to say x multiplied by p. So the final answer must always have c, because we are doing indefinite integral. So let's simplify it. Let me create more space. Y is going to be e to the power of 5x divided by 5. Do not forget, guys, natural log e is equaling to 1. So this one here is going to give us 1 multiplied by 5. So you can leave it like that. Plus, now let's look at this. 3 divided by 3 is going to be 1 multiplied by everything. So we're left with pi to the power of 3x over natural log of pi minus. Here, there is nothing you can do on the third term. You write it as it is. It's already fine. So write it like that. Now let's look at the fourth term. The fourth term, now you will be left with, on the numerator, negative half plus 1 as an exponent. It's going to give you the power of half. And then we know that if you put all this on your calculator, they're gonna give you 1. So basically you're gonna be divided by 1. Even if you don't write it, it's still fine, guys. Plus xp plus c. So this is actually our final answer. I hope you guys managed to understand this. It was not that difficult. It needed you guys to know the integral of the different functions that are given to you here. So I hope you managed to understand this. If it so happened that you got lost somewhere, you can go to the point where you got lost, and also you can leave a comment just in case that doesn't work for you. If you haven't subscribed to the channel, subscribe to the channel. And also, if this video helped you to understand, don't forget to like and also share it to your friends. Alright guys, we are done with 5.2. How about you go and do 5.3? Alright guys, so let's look at 5.3. As you can see, 5.3 is this question here. So I'm just gonna copy this question, paste it where there is space, and then we solve it. Alright guys, let's look at 5.3. 5.3, they want us to evaluate this expression that is given to us here. As you can see, this time around we do have a sigma, but this time around we have the limits, which is the upper limit is 3, the lower limit is 1. And then they want us to evaluate this. So these guys are definite integrals. I've already done a video introducing the definite integrals. I'm gonna leave the link on the description if you want to know more about the definite integrals. And also the very same video is gonna appear on the top right of this video. Click on that icon and then you watch that intro. But anyway, let's just solve this one here. So when you look at this inside the bracket, there's no simplification that is required here, so we're just gonna jump straight to integration. So let's do it. So we're gonna say y is equaling to, now let's look at the first term here. The first term, guys, is the natural log integral. So when you do this, this is gonna be 5 natural log x, and then the second term is gonna be plus 6, because this is more like constant. So the second term is actually the power rule or the standard integral. Now let us not forget we have the limit. So the upper limit is going to be 3 and the lower limit is going to be 1. So we don't write plus c with definite integral, guys, because it's going to cancel each other later on. So even if you don't write it, it's still fine. Right, so let's continue. Now you rewrite this in this manner. The first bracket is for the upper limit, so you're gonna write the integral inside there as it is, but then you write the upper limit here, and then you always subtract by the lower limit, but you also gonna write the integral inside the bracket as well. So the integral is the same, it's just the limits that are different. So this is gonna be 1. So the first bracket is for the upper limit minus the second bracket for the lower limit. So from here, we start substituting. So wherever there is x, we substitute with the limit. So for the first bracket, we want to substitute x with the upper limit. So we're going to have 5 natural log, then we say 3 plus 6 multiplied by 3. That is our upper limit. The second bracket is going to be 5 natural log, then we substitute the lower limit, which is 1, plus 6 multiplied by 1. So that is our second bracket. So from here you put this on your calculator, and then what you're going to find is going to be 17,493 unit square, because usually we use this formula or we use this method to calculate the area in a graph. So basically, guys, this is how you do the definite integral. So I hope you managed to understand this, because it was really not that difficult. I think the tricky part was to know which integral is this and that one. Then hopefully you knew those integrals. Just in case you didn't understand, go to the point where you got lost and rewatch this video. And also you can ask on the comment section. I'll try to answer and help you to my level best. And if this video helped you to understand, do not forget to like and also share it to your friends. If you haven't subscribed to the channel, subscribe to the channel. Alright, we are done with 5.3. How about we go and do 5.4? All right, let's look at question 5.4. Now 5.4 has two questions, guys. It has 5.4.1 and 5.4.2. so we're gonna start with 5.4.1 and do it, and then we're gonna do 5.4.2 later on. So I'm gonna copy this question here and paste it where there is space, and then let us analyze it and solve the problem. All right, guys, let's look at 5.4.1. now this question goes like this: draw the two sketches of y is equaling to negative x squared plus 4 and y is equaling to x. Calculate the point of intersection. Let me highlight this. And then they say clearly indicate the area enclosed by the two graphs as well as the strip. So they want you to do a lot of things here, guys, but the first thing that you must do is to sketch the graphs that are given to us here. So I'm gonna start with the first one. In this case, the first one is actually the parabola, because we do have x squared there. Now the general formula for parabola, guys, we know that y is equaling to a x squared plus bx plus c. Now when you look at that parabola there, we have y is equaling to negative x squared plus 4. Now you need to understand that we have a as negative 1 because a is a coefficient of x squared, and then b is going to be 0 because we do not have x on this equation that is given to us, and we do have c though, which is going to be positive 4. So we can able to draw this graph, but in order for us to draw the graph, we need to find the point at which we're going to connect so that we can able to draw the graph. So we're going to start by finding the intercept, then we find the turning point. Let's start by finding the y-intercept. When x is equaling to 0, what is our y? So basically what you do here is wherever there is x, you substitute with 0. So from the original equation that is given to us on the statement, we can say y is equaling to negative 0 squared plus 4. Remember, wherever there is x, we substitute with 0. So meaning y is equaling to 4. We can say this is point A. When x is 0, y is going to be positive 4. Then we are done. Then we continue. We do the very same thing for the x-intercept. So we can say when y is equaling to 0, what is x, right? So we can say wherever there is y, we substitute with 0 from the original formula. So we can say 0 is equaling to negative x squared plus 4, right? Then we can transpose this x to the left hand side, which is going to become positive x squared, which is equaling to 4. Then from there we square root both sides. So when you square root this x squared, when I have x, and then you will have plus or minus 2, which is the square root of 4. We can say at point B, when x is 2, y is 0, and at point C, when x is negative 2, y is also 0. So these are actually the x-intercept. Now remember, with the parabola we do have a turning point, so there is a formula that we use for turning point. Let me just write TP to indicate this is going to be our turning point. So the formula goes like this: for the x coordinate, it's negative b over 2a. But if we go back to this here, as you can see, b is 0. So if we substitute here, we can say x is equaling to negative 0, that is our b, to our a is actually negative 1. So we're going to put negative 1 there. But anything dividing 0 is equaling to 0. So meaning our x is 0. Now we're going to substitute the very same x that you got here to find the y coordinate for our turning point. So let's do it. So we can say y is equaling to, wherever there is x, we substitute 0. It's going to be negative 0 squared plus 4, meaning now y is equaling to 4. We can say TP, which is our turning point, is 0. And if you can look at this here, guys, our turning point and our y-intercept, they do have the same coordinates. You guys see it has 0 as x, 4 as y, both of them, meaning our turning point is the same as our y-intercept. So let me first draw this graph here so that we can able to see how the graph is supposed to look like. So let's draw it. Now when you look at this, we have the x-axis and the y-axis and also the origin. Now I'm gonna use a different color to draw this graph here. Now let's start with point A, which is here. Point A, it says when x is 0, our y is 4. So we can say this is point A, where y is equaling to 4, right? And x is 0. Now let's look at point B. Our point B is this one here. It says when x is 2, y is 0. So we can say x is 2 here at this point, and our y obviously is going to be 0 there. Let me just write it on top here. All right. And then let's look at point C. Point C states that when our x is -2, our y is 0. So we can say this is point C, where x is -2 and y is 0. And then let's look at the turning point. Our turning point says that when x is 0, our y is 4, which is the same as our y-intercept. So I hope you can able to see that. So let's continue and draw our graph. So let me use this color here, which is white, and draw our graph. So I'm just going to connect the point. Now before I do that, remember the shape of this parabola is going to face down because our a here is negative. Remember, when a is negative, parabola faces down. When a is positive, parabola faces up. We know that from our turning point is going to cut at -2, right? And the other part of it is going to cut at +2, and it should face down like that. All right, it doesn't look so good, but basically this parabola is how it's supposed to look like. There we go. We are done with the parabola. So let's look at the straight line graph that is given to us on the statement. So this graph here, it is y is equaling to x. Now you need to understand the general formula for straight line graph. So the general formula for straight line graph, it's like this: y is equaling to mx plus c. So you need to know what m is and what is c. So m is our gradient and c is our y-intercept. At the same time, as much as m is our gradient, it's also the coefficient of x. Now when you look at the graph that is given to us here, we know that m is equaling to 1, and it's also positive. Basically this means that our gradient is 1. Our graph is going to lie on the first quadrant and the third quadrant. Now let's look at c. Our c is 0 because we don't have anything after x. It's really nothing. So if c is 0, this means that we do not have the y-intercept. So that also means that our graph is going to actually pass at the original point, or the origin. So when you draw your straight line graph, guys, it's supposed to be passing at the origin. So let me use also a different color for this one here. Let me just try use maybe yellow. Let's use yellow. All right, so our graph is gonna look like this. It's gonna pass at the origin. There we go. And then it also gonna continue like that. Remember, this is a straight line graph. So this graph here is gonna intercept the parabola there on those points. Let me just highlight with red color. It's gonna intercept the parabola there. So like I said, this graph is actually the one here, y is equaling to x, while the other graph, which is the white one, is gonna be equaling to y is equaling to -x squared plus 4. So these two graphs here, these are the graphs that they are mentioning or talking about. But then at the same time, these graphs, they are intercepting each other. So we have this point here, let's call it point 1 of interception, and we have that point there, which is point 2. So these points, they do have x and y. So when they say calculate the point of intersection, they want us to find the coordinate of those points there. So let's find those points. But then in order for you to find this point, you need to know some very important information about when two graphs are intersecting. When two graphs are intersecting to each other, it means that at those points, those graphs are actually equal to each other. So in order for us to find this intercept, we need to equate these graphs. So the best way is to equate these graphs so that we can only have x to solve. What do I mean by that? You can say the straight line graph, which is going to be equaling to negative x squared plus 4. Remember, this is the parabola. So all you have to do now is to transpose this negative x squared plus 4 to the left hand side, and then you'll be left with x squared plus x minus 4, and this is equaling to 0. As you can see now, this becomes a quadratic equation now, meaning we can use the quadratic formula to find the x values of those intercepts. So let's do it. So the quadratic formula goes like this: x is equaling to negative b plus or minus square root of b squared minus 4ac divided by, all this is divided by 2a. All right, let's find our x. So let's start substituting. So we're gonna use this equation here to find these variables that are in our formula. So we know that b is a coefficient of x. So if you look at this equation here, we know that the coefficient of x is 1. So wherever there is b, we must substitute with 1. So we can say negative, and then wherever there is b, we say there is 1 plus or minus the square root b squared, but b is 1, so you can say 1 squared minus 4, but then multiply by a. So a in this case also is a coefficient of x squared, which is also 1, so we substitute by 1, multiply by c. So our c is our constant. In this case now, our c is negative 4, right? So negative 4 here, right? And then all this is divided by 2, and then a also we said is 1. So if you put this on your calculator, here's what you're going to get. You're going to have negative 1 plus or minus the square root of 17 divided by 2. So we have to find this axis. X is equaling to, let's say, negative 1 plus the square root of 17 divided by 2, and this one is going to give us 1,562. And then let's do the other this side. When we have x is equaling to negative 1 negative square root 17 over 2, this one here shall give us negative 2,562. So these are the x values of this intercept. So I'm just going to create space so that we can able to find the y values of this intercept. So let's find the y values of this intercept. So there are two ways that you can use to find the y values of the intercept. You can use this one here, x is equaling to negative x squared plus 4, or you can use y is equaling to x. Rather use the second one, guys, because you just say x is equaling to y. That's it. So meaning whatever x is, that's y. So we can say y is equaling to negative 2,562, and y is also equaling to 1,562. All right, so let's look at which point. Let's say point 1, this one here underneath. Let's see the coordinates. What are those? As you can see, point 1 is on the negative side. It means that this is going to be negative 2,562, and also y is going to be negative 2,562. That is P1. And then P2, which is the one here on top, guys, is going to be positive because it's on the positive side of x. So it's going to be 1,562 for x, and also for y is going to be 1,562. Guys, these are the intercept of the graphs since we have two of them. So this one here and that one there. So when we continue with the question, let's go back to the question. They want us to find an enclosed area created by these two graphs. So an enclosed area, guys, let me show you which is it. And also we must not forget the strip. So let me use a different color here so that you can able to identify that enclosed area. Let's start with the strip. So the strip could be anywhere in between the intercepts. So the strip, put it anywhere between the intercepts. So let's start with the strip. So this can be your strip. So make sure that the strip is between the intercept, because this intercept, they act as our upper limit and our lower limit. So let's indicate the areas that they are talking about. So I'm gonna use blue to indicate. So there will be a lot of colors here. So this area here that you see that I'm indicating, that I'm coloring here, guys, this area that I'm coloring here is the area that they want us to show. When they say indicate the enclosed area by these two graphs, this is basically what they mean here, guys. Right, I hope you can able to see. So your graph was supposed to look like something like this. So you must have an enclosed area, and also you must show the strip which is between the intercept, because those intercepts are the ones where this graph actually form an area. So I hope you guys managed to understand this. This was a bit long and also a bit complicated, because if you didn't know what was happening here, this question here was gonna be challenging for you. I hope though you managed to understand. If you didn't understand, you can go back to the point where you got lost and try to rewatch. And if that doesn't work as well, do not forget to comment. I'll try to help you to my level best. And also, guys, if really this video here help you to understand, don't forget to like, and also don't forget to share to your friends. If you haven't subscribed to the channel, subscribe to the channel. Alright guys, we are done with 5.4.1. we are going to do 5.4.2, but then here's what you need to know. 5.4.2 is a continuation of 5.4.1. so you need to understand that this graph here, we're going to keep it, and also the intercept. Alright guys, let's go into 5.4.2. So guys, let's look at 5.4.2. Remember, I did mention that 5.4.2 is a continuation of 5.4.1. Just in case you're about to watch this question, make sure that you've watched 5.4.1, because you won't understand anything that has to do with this question if you did not watch this one here. So let me copy this question and paste it where there is space, and then I will continue from there. Let's continue with 5.4.2. Now the question states that calculate using integration the magnitude of the area indicated in question 5.4.1. Like I said earlier on, you need to have watched 5.4.1 in order for you to understand what is happening here. But I also took the graph that you see here. It's from actually 5.4.1. so they want us to calculate the area of this graph here. Look, that area that they're talking about is the blue color of this graph here. So the blue color indicates the enclosed area that they want us to calculate. Now, in order for us to calculate this area, we need to use the definite integral. I've already made videos on definite integrals, so just in case you don't know what's happening there, you can go to the description. There is a video already that I've pasted earlier on. Go to that link, click on that link, and you will see a video that explains more about definite integral. We need to find what is our upper limit and our lower limit. Remember, we have 2 points here. We have P2 and P1. Now, we're gonna look only for the x values of these points. Remember, these points, by the way, are the intercept. So also, we're only gonna take the x values of this point here. So the upper limit should be the highest number when it comes to the x values here. So the highest number is the one that is 1,562, and the lowest number is the one that is negative 2,560, meaning that the upper limit is 1,562 and the lower limit is going to be negative 2,562. Right, these are the limits, because when you look at the x-axis, that's where our area starts and that's where it ends. So now, how are we going to write the equations here since we have two graphs? What you need to understand here, these two graphs, the one that is upper, in this case now, the one that is upper on this area is our parabola. It's going to be positive. So it's going to be subtracted the one that is lower on our area, which is going to be the straight line. So you're going to do the following. Remember, the equation of the upper is negative x squared plus 4 minus, so it should be minus by the straight line equation, which is minus x. Remember, the equation is y is equaling to x, then dx. Then from there you start integrating. As you can see, this is a standard integration, so you don't really have to worry about it. So let's start. So you can say a for area is equaling to, let's find the integral of this here. It's going to be negative x squared plus 1 as a power divided by 2 plus 1, right? Plus, now let's look at the second term, which is 4. You just multiply by x since we are integrating with respect to x, minus, and then the last term, which is going to be x to the power of 1 plus 1 divided by 1 plus 1. Now the second step that you must follow this one is you write the upper limit, which is 1,562, and then the lower limit, which is negative 2,562. Then from there separate these limits. So you can say a is equaling to, you're gonna have two brackets, one for the upper limit and one for the lower limit. So the first bracket is for the upper limit, so it's going to be negative. Then we simplify the integrals inside there, which is going to be negative x cubed divided by the 3 plus 4x minus x squared divided by 2. Then the first bracket is for the upper limit, so you write the upper limit here, 562, minus, always guys, the first bracket is minus by the second bracket, which is for the lower limit. So you're going to write the integral that you wrote on the first bracket as it is, minus x squared over 2. Then you write the lower limit here, which is going to be negative 2,562. These are not powers, guys. This is to indicate that the first bracket is for the upper limit and then the second bracket is for the lower limit. So the next step here, you just substitute wherever there is x, you substitute with the limit. So the first bracket here, wherever there is x, you substitute with the upper limit. So let's start. So we can say negative, and then we say 1,562 cubed divided by 3. Remember, where there is x, we substitute with the upper limit, plus 4 multiplied by 1,562 minus 1,562 squared divided by 2. So this is actually the upper limit. So minus, wherever there is x here, we substitute with the lower limit. You can say negative, and then we say minus 2,562 cubed divided by cubed, right? Plus, wherever there is x, don't forget we substitute by negative 2,562, right? Let's create more space, and then the last term we can say minus negative 2,562 squared divided by 2. So this is for the lower limit. So from there we put all of that in our calculator. So for the first one here, it's gonna be 3,758, and the second one, which is gonna be plus 7,924. So when you add this together, it's gonna give you 11,682 units squared. Don't forget we are calculating for the area. Alright guys, so this is how you actually do this question here. It was a bit challenging. I hope you guys managed to understand this one, because really it needed you to understand what was happening on the previous question. But anyway, if you did not understand, I would say go back to 5.4.1, watch that part of the video, and also come back to this one as well. If you manage to understand that part, you can rewatch this one here, and then you will also try to figure out where you got lost. Just in case that doesn't help, don't forget to comment. I'll try to help you to my level. best. Alright guys, if this video helped you to understand, do not forget to like the video, share the video to your friend, and if you haven't subscribed, subscribe to the channel. Right, so this is the end of question 5 of this question paper, and also it's the end of the entire question paper. So guys, thank you very much for watching. If you want to watch the whole entire question paper, there will be a video that will pop up at the end of this video, and then the playlist as well. Thank you very much guys. Till next time, cheers.